Hello everyone, welcome to our channel Public Cloud Design Tips and Tricks. In this channel, we are going to discuss about public cloud design problem statement and their related solution. Today, we are going to discuss about Azure SQL Hyperscale database and its new preview feature Auto-Failover group. Now, let's try to understand what is our problem statement. So, our problem statement is how to meet the exponential growth of SQL database. That means if you want to increase your database or your SQL database exponentially, that means the size is very high. In that case, what is the best solution that public cloud provides? Or if you have a large SQL database that is in your on-premise and you want to migrate it to public cloud, then what should be your solution? To achieve this, Microsoft Azure provided Azure SQL database, AWS has provided AWS RDS, and Google Cloud has provided Google Cloud SQL. Now, let's try to understand what is Hyperscale database. Before that, let's try to realize Azure SQL database is based on SQL Server Database Engine architecture and it provides 99.99% availability. There are three architectural models which Azure SQL database supports. One is general purpose or standard, second is hyperscale, third is business critical or premium one. So a hyperscale database is the type of or a tier in SQL database that is based on hyperscale scale-out storage methodologies. When we say hyperscale scale-out storage methodologies, that means it can support up to 100 terabytes of data, high throughput, excellent performance, and rapid scaling based on the expansion. Now, let's try to realize what are all different hyperscale capabilities. That means what are all different capabilities that you can get with Azure SQL database with hyperscale feature. So with this, you can get elastic growth of database that is up to 100 terabytes, fast backup that means quick storage of snapshots, fast database restores regardless of database size that is from storage snapshots, higher log throughput, read scale out using one or more read replicas used for read uploading and as hot standbys, rapid scale up of the compute power, rapid scale down when load is less. That means if you have a high load, in that case the scale up and scale down can be managed automatically. Grows based on the demand, charged based on the usage, pricing is based on the vCore model. That means compute, memory, input out IO and storage limit. Now let's try to realize different components of hyperscale database. As you can see in this diagram, there are different components of SQL database, hyperscale database. One is compute nodes, second is page server, third is log services, and fourth is Azure standard storage. So let's try to understand what is a compute nodes. So compute nodes is used for SSD based caching called resilient buffer pool extension RBPEX. The primary compute node does all the read write workloads, whereas the secondary used for the standby, and it can be used for read workloads as well. Second is page server. A subset of page is the database. That means a database is the subset of a page. So it can handle up to 1 terabytes of data. It keeps the pages updated, the transaction changes using a log service. And the page server also uses RBPEX data cache for fast response. Now the third component, log service. The log service receives the primary compute replica log records, which passes them in the durable cache and transmits them to the secondary replicas. Second, it also sends these logs to page servers. So all the secondary compute replicas and respective page servers receives the data changes. So this is how the primary and secondary sync with each other. It also pushes log records to the Azure standard storage for long-term retention. Now the fourth one, Azure storage. The Azure storage stores all the data files of the hyperscale database. The page servers update these data files and keep them up to date. So the storage will keep them up to date based on the data files. Azure uses storage snapshot of data files for backups and restoration of the database. So in case of any database deletion, then for the backup you can get the data from the Azure storage. So these are all 4 components of Hyperscale database. Now let's try to understand the new feature of the Hyperscale database, that is known as Auto-Failover Groups. As the name suggests, the system will automatically redirect from your primary to your secondary database. So it supports geo-replication, including ability to failover the entire group of database. As you can see here, when you are adding more and you are enabling the Auto-Failover groups and you are adding multiple database inside it, so the database can be in one region or it can be in another region. So as you can see in this diagram, there are 2 databases, primary SQL server and another is a secondary local SQL server. And in primary SQL server, you have 2 SQL database, and in secondary SQL server, you have 2 SQL database. And as you can see here, the read-write listener will redirect the request based on the the server which is available, and the Auto-Failover group makes sure the request will always goes to the right server. Whenever the primary server is down, then the request will go to the secondary server. That's how Auto-Failover groups enable the higher capability or higher availability of Azure SQL Hyperscale database. This feature is in preview phase. Please follow the Microsoft document to understand more about this feature. We have gathered all this information by following these links. If you want to learn more about it, please follow the description of this video. You will find all the details about the Azure SQL database and Hyperscale feature. Please read out, and if you like the video, then don't forget to subscribe our channel and stay updated. Thank you.